Welcome to our first video for worked out homework solutions. This is the prerequisite for calculus video 1, and just for future reference, the ones in yellow are going to be, I'm just letting you know those are the ones I took for a grade for accuracy, and then the total completion of the assignment I also take into account just to have it completed. But it just helps me for grading the ones I deem the most important, and the other ones are also important, but they're either like a repeat or something that I'm not going to grade for accuracy. So your homework will be graded on completion and accuracy. Okay, the first problem was pretty simple. We had to plot 2 coordinate points. So really, when you're asked to plot, if you don't have graph paper, that's fine. I do recommend getting some graph paper if you're somebody that likes to be a little bit more neat, but for just plotting something like this, you don't necessarily need it. So let's plot the coordinate point A, -2, -1, and then coordinate point B at 1, -2. And part A just said to plot them, and then part C said to draw the line through them. So I'll draw line L, to graph line L, and we'll call that line L. Okay, part B asked us to find the slope. You could do this in a couple ways. You could just go from the left point to the right point, A to B, and see that we're falling 1 and running 3, so our slope's -1/3. You could also find that the slope is -1/3 by just doing it with the slope formula. So our slope formula is y minus y, so I'll take -2 minus -1. And then x minus x in the same order, so 1 minus -2. A lot of very similar numbers in this one can make it a bit confusing. When you have minus a negative, which we do in both cases here, that turns into one giant plus sign, plus, plus. So -2 plus 1 is -1. In our denominator, we'll have 3. We can't simplify that, and that's our slope. For 14, you were asked to write this as a line in point slope form. So remember, point slope form is this formula where you plug in m, x1, and y1. So this is our m, this is our x1, and this is our y1. So if we just go to plug it in, we'll have y minus y1, so y minus 1, equals our m, which you can put a -1 there, or you can just put a negative symbol. That both means, the same thing. So either way is fine. And then we're going to have x minus -1, which is x plus 1. So this is point slope form. That's our final answer, so I'll box it. Number 18 simply asked us to write in slope-intercept form, which is y equals mx plus b. And we're literally given m and b. This one's very simple. So we just plug in -1x and then plus 2. Again, you don't need to write the -1 since it's a coefficient of x. You can just put the negative sign. Okay, this one might have been a struggle for some of us just because it is a word problem, right? So sometimes we have that mental block. But it says that a car starts from point P at time 0 and travels at 45 miles per hour. So this is a key thing, is 45. And instead of mph, I'm going to write miles per hour. Note that this is a slope. This is how many miles we travel per 1 hour. This is 45 over 1. So mph is really a rate or a slope. So it says write an expression d of t for the distance the car travels from point P. Okay, so if you're traveling 45 miles per hour, you're literally going 45 miles every hour that you travel, and the hours are measured by t. T stands for hours, so it says to write it as d of t, so the distance based off of the time is you travel 45 miles every t hours, and that's it. We're not starting anywhere, we're starting at 0, right? Point 0, so there's technically a plus 0 here at the end, but we don't need to write that. So this is really slope-intercept form. Here's our slope, here's our independent variable, and this is our dependent variable, d of t. The time affects the total distance traveled. Distance is dependent upon time. In part B, we're asked to graph, and again, it can just be a quick sketch. So we know that we're starting at 0 and we're our total distance, our total miles is only positive. So we really only care about the first quadrant. So this is our t-axis instead of our x, since that's our independent variable. And if you want, you can label this one d of t, since that's our dependent variable. If you labeled it y, that's fine, because in the problem it does say y equals d of t. Now, how do we label this? Our minimum amount of hours is 0, and then we can travel 1, 2, 3, and so on. That's sufficient. And then we know that every hour that we travel, we've gone 45 miles. So I'm just going to go up by 45s to keep it simple. Oops. And then we know that after 1 hour, we've traveled 45 miles. So then that means after 2 hours, we've traveled another 45 and so on. So we're just going up by 45 every time. And then at 0 hours at the very beginning, we haven't traveled at all. That's a very big dot. Whoops. And then we're going just up. So that is a line there. And it begins here. It does not go indefinitely in both directions, only to the right. What is the slope? The slope is literally 45, or 45 over 1. And what does it have to do with the car? Well, this means that the car travels 45 miles per every 1 hour. If you had something like that, that's perfect. This next one is a true or false problem, and we do have to justify our answer. So we can't just answer true or false. That's only the first part. We have to justify and give a reason behind why we decided true or false. So it says the slope of a line perpendicular to this line is 1 over m. Well, we know that perpendicular lines have opposite reciprocal slopes. So the opposite reciprocal of this slope m would be negative 1 over m. So it's not 1 over m. So we're going to say false. The opposite reciprocal of m is negative 1 over m. This answer is sufficient. It's straight to the point. It answered true or false, and then it justified. 52 is multiple choice. It's asking us to find the equation of a line, and they're all in slope-intercept form. All of our answers are. It's asking us to find the equation of a line that passed through this point and is parallel to this line right here. We know parallel lines have the same slope. So the information that we're getting from this is that our slope is also negative 3. Note that we do not care about this 1. So now we have enough information right here to go into either point slope form, or you can go right into slope-intercept form. It's up to how you like to solve this. I'm going to use point slope form because we literally have a point and a slope. So we're going to have y minus negative 1 equals our m and x minus negative 2. Note that instead of minus and negative, I'm just writing plus. And then what we can do is distribute, because we need to solve for y, since all of our answers are solved for y. So we'll distribute our 3, and then we'll subtract, oops, and I made an error. Look at that. I did not correctly distribute the negative 3. So that needs to be minus 6 instead. There we go. So I distributed the negative 3, like I said, and then we'll subtract 1 from both sides. So we'll be left with y equals negative 3x minus 7. Now that answer choice is B. For these two problems, 6a and 8a, I'm just asking you to find the domain and the range. So, and I said you should use your calculator because visually it's much simpler. Now, x squared minus 9 is a quadratic function, and it forms a parabola, and as you can see, it has a vertex down here at negative 9. So I got this actually not on my graphing calculator, but I got this picture for you guys on Desmos, which if you Google this, it's a great free online graphing calculator. If you're ever in a bind, you can totally use it. So let's find the domain and the range. Oh, and I added these arrows here. So the domain is basically what can we plug in for x? Well, we notice that we can plug in anything we want for x. X is not under a square root. X is not in a denominator, places where there could potentially be issues. We also look left to right, and this arrow means that this is going forever up and left, and this is going forever up and right. As we look left to right, we have no restrictions. So our domain is all real numbers, or you can write it as negative infinity to positive infinity interval notation. That's our domain. Our range is what our output can be, our y values, which we visually look down to up. So we see that we do not extend indefinitely down to negative infinity. Instead, the first value that we take on is -9, and then we take on all values vertically upwards. So we can take on -9, so we can, that was bad, so we can include it. So we put that closed bracket, and then we can go all the way up to positive infinity. Okay, this one was kind of a weird function with both of the negatives here, but the overall shape of a square root function is just an arc. Just like the overall shape of an x squared, a quadratic is a parabola. That -9 in the previous just shifted it down 9. It's the same general shape. Same with this. Both of these negatives here flipped it down and like across. Normally it would be going up and to the right as an arc. Either way, I got this on Desmos again, and we're looking for the domain and the range. Now clearly there's an issue with domain, right? We have x under a square root, and we can't have negatives under a square root. That means we actually can only plug in negative numbers under here because it's like a double negative would make it okay. We can also plug in 0 because it's okay to take the square root of 0. That's algebraically a way to figure it out. If you look on the graph, we can see that from left to right, we're forever left, so negative infinity, all the way until 0. That's the last x value we take on. So our domain is negative infinity to 0, and we can take on 0. So that's our domain. And as a reminder, infinities, positive or negative, always have the open parentheses, never the bracket. Okay, our range, we want to look down to up. And we can see that this extends indefinitely down and also left. So negative infinity all the way to 0 again. 0 is the last y value that we take on going upwards. So the domain and range are actually the same in this case. So your calculator can really help you out. If you can't look at this and know what it looks like, that's fine. Graph it on a graphing calculator, go to Desmos online, and there's plenty of other ways that you can get a graph of a function as well.